Ladies and gentlemen, welcome to the next session of our text session. For Q&A, kindly key in your questions at the Q&A chat box. Do visit our virtual exhibition and discover the latest water innovations and technologies. The exhibition will be live for 24 hours during this whole week. Do enjoy the next presentation.
Mr. Ellis, you can start.
You haven't got the name slide of the speaker. Speaker name slide, according to the script. Okay, good. Am I on now? Yes, okay. Good morning, everyone. Assalamualaikum, selamat pagi, salam sejahtera. My name is Engineer Ilyas Saidin. I'm a council member of the Malaysian Water Association and moderating today's session on the 5 topics and presenters up to 2:30 p.m. today. This morning, to kick off the presentation, we have who is actually presenting pre-recorded, live, pre-recorded, not attending live, pre-recorded. Her name is Natalia Puspa Devi Pelipus from the Department of Irrigation and Drainage, Malaysia. A brief introduction. Madam Natalia Puspa Devi graduated from University Technology Malaysia with a degree in civil engineering in 1999 and a master's degree from University Putra Malaysia in 2013. She served in the civil service in 2002 with the Department of Irrigation as a civil engineer in the Irrigation and Agricultural Drainage Division. Currently, she's the Principal Assistant Director for the National Flood Forecasting and Warning Center at BID. Since 2019, she has been leading Flood Modeling Unit, responsible for the development of National Flood Forecasting and Warning System for the northern region of Peninsular Malaysia. Ms. Natalia, please proceed with your presentation, or rather pre-recorded presentation. Thank you.
Salam sejahtera and a very good morning, ladies and gentlemen, members and participants of Malaysian International Water Convention. My name is Natalia Puspadewi from National Flood Forecasting and Warning Center, Praban, Department of Irrigation and Drainage, Malaysia. So for this morning session, I would like to share a paper based on our experience in developing flood forecasting models for river basin. So the title of my paper this morning is The Challenges on the Development of Hydrodynamic Flood Forecasting for Small Urban Basin. So for this presentation, I'm going to address on the few outline. The first one will be the introduction, which I will be touching on the criteria of flood forecasting models, definition and component of flood forecasting. Next, the project area, followed by development of flood forecasting model, which I'm going to focus on the data management and its challenges, and modeling approach and its challenges, and finally conclusion. So flood has been a common issue in Malaysia due to the rapid urban growth in this country and the land use changes and also the abundance of rains. Okay, so major floods has caused a disaster that threaten the life and also severe damage to the properties and disrupt social and financial, social and economic activities. And flood forecasting also is one of the non-structural measures has been taken to reduce flood risk. So since 2007, DID has developed many flood forecasting model using a hydrodynamic approach. So the ID has developed and currently has operating the National Flood Forecasting and Warning System (NAFAS) for Sungai Pahang, Sungai Kelantan, and Sungai Terengganu. So before we move further, it's good that we can understand the criteria that is important in flood forecasting model. Okay, the first criteria will be timeliness. Timeliness means that forecast must be available in the shortest possible time from measurement of the rainfall in the catchment. And the second one is accuracy. So means that the model need to forecast and must forecast accurate so that accurately so that both the authorities that preparing the emergency action for instance in this country is NADMA, National Disaster Management Agencies, and also the people that affected on the ground have a fully confidence in the system. Okay, and next is reliability. Reliability means that the model must be reliable and also able to function well during any severe condition or extreme condition during a major storm and disaster. So the final criteria is adaptability. So adaptability means that the model should be able to adapt to the impacts of the future man-made future man-made impact or structural intervention in the catchment. And it's good also that we can understand what is flood forecasting all about. So the flood forecasting is dealing with the variation of water levels and flows in the river, and it has to do with a specific point of time which can close up to hours or days through the computer models. And it is also aspect dealing with measurement of rainfall, which is through the remote transmission, okay, which it is placed rainfall station for forecasting using incoming rainfall in the basin. And finally, for flood forecasting, dealing with decision-making support system. Okay, this is used by flood managers to put confirm decision and finally disseminate to the agencies and people in the ground. Okay, and for further understanding, we need to know what is the component of the flood forecasting as well. So there are four components. The first one is data management. Data management is something that deal with the management of the real-time data from the field. For instance, is rainfall data. So it is good that we have it is very important that we have a good quality data. Okay, the second one will be a the forecasting, which is running computer simulation models to predict what will happen in the river basin. Okay, and third will be updating real-time updating procedures that automatically adjust any kind of model computation to take maximum advantage uh, of available real-time information. Okay, this is taken from the field. So the fourth uh, component is the decision support, which is dissemination module that allows fast graphical and also tabular presentation of forecast uh, uh, and actual water levels and also reporting. So next, I'm going to touch on the project area, which is based on the National Flood Forecasting and Warning System of Zone 1, which is located on the northern region of Peninsular Malaysia and find downstream to the Sungai Jawi Basin. So Anapa Zone 1 is currently under development stage, which cover 11 river basin, which is prone to flooding. Okay, so this 11 river basin consists of Sungai Perlis, Sungai Melaka of Langkawi, Sungai Kedah, Sungai Muda, Sungai Pinang, Sungai Perai, Sungai Juru, and Sungai Jawi, Sungai Krian, Sungai Kurau, and Sungai Perak. So before we move further, it's good that we know the land use that is being considered in this river basin, which is close to the application of the model. So in this zone 1, we have 11 river basin, which basin areas range from the smaller size is 52 kilometers squared, which is Sungai Pinang, to the largest basin area, which is Sungai Perak, size with size of 14,824 kilometers squared. And the land use for this river basin is varies from from rural to the mixed and urban. So for this case, we focus on Sungai Jawi, which has the one of the small river basin in this zone 1, which land use is urban. For urban is much more challenge compared to the rural area, which is much more straightforward in terms of modeling analysis. Sungai Jawi Basin, the river system consists of two major river systems. So first one is Sungai Jawi, which is about 32 kilometer in length, and the main river length. And Sungai Junjung is the main rivers, which is 23 kilometer in length. Okay, so the topography of this basin is majority is less than 50 meter, with the maximum height is about 460 meter. And this is the aerial view of Sungai Jawi run across the north-south highways, expressway. Okay, and the lane use can be seen from this photo is to have industrialization nice area with some part of residential area. And the flooding issue also happened in this basin, which is mostly can be seen from the picture is in the town or city area and also in the villages or residential area. And next, I'm going to touch on the development of this flood forecasting model. Before we move on the detailed part of the development, it's good that we can understand the comparison between rural and also urban river basin characteristic, and also we will know what is the objective expectation. So for rural catchment area, it has pervious surface or pervious condition, while urban is an impervious condition, and in rural natural stream, but in urban we have line, channel, and very less natural stream. Apart from that, rural mostly are low density population compared to the high density population in urban area. So it means that in rural is less human interference, but in urban there are many human interference. And this rural also is sensitive to long duration storm, while urban is much more sensitive to short duration storm. So what is the objective expectation of this flood forecasting model? First, we need to have an accurate model, means that the model is producing a good result, accurate result, which depend on a good data. And second, be fast. So model produce fast result simulation, which much more depending on the engine or the hardware or the software part of modeling system. So in achieving the objective, we have focused on two aspects. The first one will be data management, and the second one will be the modeling approach. So for the data management, there are a few challenges that I list down in this paper. So for the first part, we will see on the river cross section, and then followed by the digital terrain model data, and we can see detail on the difference between LiDAR and IFSA, and also difference between the river survey and the DTM. Management, there are two models that we need to understand the data requirement. Okay, for the hydrological model, it involves subcatchment properties, okay, which is land use, okay, and also rainfall data. And for hydrodynamic models, there are more river information models, information, for instance, river cross section, and also structures that we need to understand, and floodplain features. So for this Jawi modeling, we have find out and identify a few challenges that that need to be considered in the modeling or need to be considered during the development of this flood forecasting model. So the first one will be the size of the basin, which is this Sungai Jawi basin is much more smaller. So due to the small, so it has short lag time, which is ranging from 1 to 6 hours. So apart from that, the land use of this Sungai Jawi Basin is much more to urbanize and large land use variation. So this is need to address well. So due to the urbanization, so it has a lot of man-made interference to the river system. Okay, so next, there is also a challenge on how to differentiate between the river flood and the locust flood. So finally, we find out that the complexity of the modeling also is an aspect that challenge in the that become a challenge in this developing of modeling flood forecasting. This is both for hydrologic and hydraulic model. So for the hydraulic model, the hydrodynamic model, uh, it is very important that we have a good river cross section system, which taken from the survey of rivers engineering survey. So this from river cross section, we can finally plot out river profile from the upstream to the downstream. And for DTM or digital terrain model, we have two type of model that we obtain. It's LiDAR and also IPSA. So LiDAR has more resolution, which less than 1, and IPSA is up to 5-meter resolution. So based on these two result data, so you can see that LiDAR data produce more clearer information on the infrastructure compared to IPSA. We also are having kind of challenging time when want to analyze the survey and the DTM data as well. So survey is when we comparing the survey and DTM data, for instance, in this diagram, we can see that Sungai Binjai has a difference of 0 to 0.5 while using a LiDAR, while using IPSA, the difference is up to 1 meter. So it is really shows that if LiDAR data has the good resolution and can have a really close agreement with the survey data. And so for this case, that the river engineering survey also should be representing the inlet, the in-bank channel, okay, which shows the riverbed level, and the DTM data represent the floodplain. So riverbank shall be a connection of flow between in-bank, okay, in-bank and also the floodplain here. Okay, so the challenge happen when we want to find or we want to make a decision on what kind of river survey, what kind of DTM data that we want to use for the floodplain management. So next we want to see on the man-made interference with this data management. So there are few man-made interference that we are identified in this basin, which are pumping system, crossing and bridge, bund and flood wall, and also tidal control gate. So for pumping system, there are few pumping system in this river basin. So we need to understand the SOP or the standard operating procedure for this um, pumping system and also the TCG, tidal control gate, SOP, so that we can put in the models, and model can produce a very reliable result. And crossing as well from any structure which is bridge or um, uh, crossing any kind of structure. For this case, like KTM Bridge, Sungai Jawi also must be taken into account. And finally, the borrow pit also become major drainage system in the area that we need to address and need to put in the model. And bund and flood wall, okay, bund and flood wall is the features and the flood plain that is very important. Okay, and next challenge we will see on the modeling approach, which is two major issues here is the runoff and also the calibration. So for modeling approach, it's good that we have a 2D models, which is we have which covers and captured all the information on the ground being put in the model. For instance, this bund, bridges, and any kind of structures. So apart from that, a good satellite image can help us to have a good model by putting the infrastructure exactly for this case is highways and any kind of structures that cannot be identified using DTM and survey, river engineering survey. So the challenge in this modeling approach is how to understand the graph of the um, runoff and also discharge, okay, in the system. So the red color is resemble the natural system without less interference, okay, but the green dotted straight line is the discharge in the river system due to the human-made interference. So next will be the calibration. So calibration has been an important role to make sure that model is able to work according to the recognition and provide good result. So for this good observation data, it's much more easy to get a good calibration. Okay, but for poor observation, for instance, the down picture here, this really need a better understanding for us to produce good model. So other than that, we're going to see what is the challenge in the short lag time. Okay, for this model, we run for using InfoWork ICM. For instance, we use 4 days rainfall event, and we try to figure out the appropriate maximum size that can produce result or simulation within less time. So finally, we find out that the mesh size of 1,000 to 2,000 meters squared has produced simulation time less than 12 minutes, which is much more fast or very time safe. This is one of the flood simulation of Sungai Jawi, which can be seen here that the flood is occur in this major area, and this area resemble the flood that caused by river outflowing, and this area is basically due to the drainage system, is so-called flash flood, while the river flood is also known as monsoon flood. Finally, we have summarized the model development duration, okay, by taking care of survey works, data processing and model works, and also model development, and also testing and commissioning. So all together is up to 19 months, which is kind of reliable and realistic. So for this, from this development process, we can clearly see few conclusions that can be made. The first one is urban flood caused by short duration storm requires fast modeling output. So means that next finding, hydrodynamic 2D modeling usually need time to compute. And the third one, development of river modeling should be carried out using accurate data and additional precaution. And finally, info work CM, which is software that we use in this development, really provide fast computation and also produce reliable result, okay, for urban. So that's all for my presentation this morning. Thank you very much for your time.
Okay, everyone. That was a good presentation by Miss or Madam Natalia Pushpa Devi. I think she presented a very concise process of what DID is doing in modeling and taking care of us in terms of flooding that will happen in the river basins in Malaysia, particularly. For me, quite educational. For those who are in the industry, may want to contact her directly. For viewers who wish to ask Q&A questions, there's an email in the notes, or I can read here the email to be sent to protem at where is it? Anyway, you can always contact them through water@protemgroup.com. You can email any question that you wish to address to Ms. Pushpa. I think I have some personal experience actually looking with this since the flood forecasting coming in. We start to see big levees coming up by the river, and also hard structures, especially in Kota Baru. If you go to Pantai Cinta Berahi now, you can see high concrete walls hiding views of the river, unfortunately, but it will inshallah protect from the annual floods that's in the East Coast during the monsoon. I think without much further ado, I don't know, I hope you do communicate with her direct because she's not live. Any query that you may have, you can always go to Malaysian Water if you wish, or through the email that described here. Okay, with that, we conclude the first speaker. We await for the next session speakers.